Let's learn about factors. Our learning goal is, I can use different strategies to identify the factors of a number. And our language goal is, I can talk about numbers using words like factor, and greatest common factor. To find the factors of a number, we need to find all the numbers that can be multiplied together to get that number. And we have a couple of different strategies that we can use. Today, we're going to review a factor rainbow and a factor tree. Now, remember that the word we use for the answer to a multiplication problem is product. And the numbers that we multiply together to get the product are called the factors. Every composite number can be written as a product of its factors. So let's look at an example of this. 4 and 6 are factors of 24. And when we multiply the factors 4 and 6 together, we get the product, 24. Now, since composite numbers can be written as the product of their factors, and division is the opposite or inverse operation to multiplication, we can also use division facts to think about the factors of 45 or any other number. For example, 45 divided by 1 equals 45. 45 divided by 3 equals 15. 45 divided by 5 equals 9. So 1 and 45 are factors of 45. 3 and 15 are factors of 45. And 5 and 9 are factors of 45. Now let's look how we can apply these division facts to a factor rainbow. So we can use these division facts to find the factors of 45, and we can record the factors as a rainbow. Here we go. So we have our factors 1 and 45. Multiply them together, we get 45. We also have 3 and 15. If we multiply those together, we also get 45. And 5 and 9, when we multiply those two numbers together, we also get 45. Now, the factors of 15 are 3 and 5, which are already in the rainbow. So we don't need to break down the number 15 any further, even though, yes, it is a composite number. And the same goes for 9. The factors of 9 are 3 and 3, and 3 is already in our rainbow. Now, there are no numbers between 5 and 9 that are factors of 45, so we know we have found all the factors. And I'm going to walk you through in this next step how we can be really systematic to make sure that we have not missed any important steps. So here's our rainbow again, and we're going to talk about how we can use this to visualize all of the factors of a number to make sure we're not missing any. So the way to do that is to be systematic, because if we're very systematic, we're less likely to make errors. The way I like to do it is to start at 1 and work up from there. So I know 1 times 45 equals 45. So I'm going to write that in, and we call them a factor pair. Two numbers that are multiplied together to make a product. Those two numbers are called a factor pair. Now, if I'm being systematic to make sure I don't miss any factors, I'm going to ask, is 2 a factor of 45? Now, I know 45 is an odd number, so that means it's not divisible by 2. That's the definition of odd. So I'm going to say no. But you can always use a calculator to check. And if you do that, you'll find that 45 divided by 2 equals 22.5. 22.5 is a decimal, not a whole number. So that confirms that 2 is not a factor of 45. So we can skip over 2. Let's try 3. Yes, 3 times 15 equals 45. Those are whole numbers. And so we know that they're factors, and we can write them in on our rainbow. 3 and 15 is a factor pair of 45. And what about 4? That's the next number. Again, use a calculator to check if you're not sure. Did you get a whole number? No. So 4 is not a factor of 45. Next is 5. Now I know that 5 times 9 equals 45. So yes, 5 is a factor of 45. And we have 5 and 9 as another factor pair of 45. And you see we have built our rainbow again, this time using the factor pairs that we arrived at through our division. Now, if you're not sure about 6, 7, 8, you're going to want to try them. I'll try 6. I'll use my calculator. I get a decimal number, not a whole number, so I know 6 is not a factor. I'll try 7 and 8, also not factors. And then we get to 9, which is already part of the factor pair with 5. So that's how we know we've come to the end. We have got all the factors of 45 and we didn't miss any because we were very systematic and we went through each one. So we can confidently say the factors of 45 are 1, 3, 5, 9, 15, and 45. Now, I notice that some of these numbers are prime numbers. So we can sort the factors into 2 categories. 3 and 5 are prime numbers, 9, 15, and 45 are composite numbers, and 1, as we know, is kind of in a category all its own, so it's off to the side. Now, what if we wanted to find only the prime factors of a number and not worry about any of the composite factors? Well, that's where our factor tree comes in. Because sometimes we want to just find the prime factors of a number. So we can use a factor tree to find the prime factors. And that means the factors that are prime numbers. So if we start by writing 45 as the product of 2 factors, and it doesn't really matter which 2 you choose, so I'm going to go with 9 times 5 because that's a nice, easy fact that I know that it's one of my favorites. 9 times 5 equals 45. So 9 is a composite number, so we can factor it again. 5 is a prime number, so we're not going to be able to factor it any further. 3 times 3 is how we get to 9. So we know 3 and 3 are a factor pair for 9. 5, of course, is a prime number, so it's just 5 and 1. But we already know that 1 is not a prime number, so we're not going to include this in this because we're looking only for the prime factors. So we get to this stage where we see, well, we have the number 3, that's a prime number, and 5, that's a prime number. And if we say 3 times 3 times 5, we do get to 45, so we know we haven't missed any. And we have arrived at the prime factors of 45, which are 3 and 5. So a factor tree is a great way to help you find the prime factors of a number. We can use a Venn diagram to help us find common factors and the greatest common factor. Let's look at factors of 12 and factors of 18. Okay. Our factors of 12 are 1, 2, 3, 4, 6, and 12. And the factors of 18 are 1, 3, 6, 2, 9, and 18. A little out of order, but they're all there. Now, to find the common factors, what we want to do is identify the numbers that are the same between both 12 and 18. And I see a few right off the bat, starting with 1, 2, 3. So what we'll do with the Venn diagram is we'll move all the numbers that are the same into the middle because it applies to both. So the common factors of 12 and 18 are 1, 2, 3, and 6. 4 and 12 are only factors of 12, not 18. And 9 and 18 are only factors of 18, not 12. But 1, 2, 3, and 6 are factors of both, so we call them common factors because 12 and 18 have those factors in common. Now let's look at how we can use the same strategy to find the greatest common factor. And it's pretty straightforward. All we have to do is look at those numbers in the middle of the Venn diagram, the common factors, 1, 2, 3, and 6, and decide which one is the largest of those common factors. Now, when I'm looking at these common factors, 6 is the biggest one of those numbers. So I'm going to say that 6 is the greatest common factor of 12 and 18. So to review, we look at the common factors, and for 12 and 18, the common factors are 1, 2, 3, and 6. And then the greatest common factor will be the greatest number among the common factors. And when we look at 1, 2, 3, and 6, 6 is the greatest of those four numbers. So it is the greatest common factor of 12 and 18.